So like if you had 69 kilometers here edge to edge and you measured center to center, maybe you got 71. So I don't know. If you're within the same kind of ballpark for the velocities, we'll call that good. So actually, if you could flip back for a second, there's one thing I didn't give you that I totally forgot and definitely should have on this page here was some symbols. So for distance, if you remember, the symbol for distance is d. The symbol for time is t. For velocity, we had displacement, which is d with an arrow above it. Time is still t. The one thing I didn't do was I didn't give you variables for speed and velocity. So velocity is a vector, so whatever it's going to be has an arrow above it. The velocity one is actually going to be the one of these two that actually makes sense. Velocity starts with the letter v, so the symbol for velocity is v with an arrow above it. The one that doesn't make sense is speed. Speed starts with an s, so the symbol for speed is actually lowercase v.
Why?
Because it's the magnitude of velocity, and velocity is the one we actually care more about. S is something else. Seconds. That's a pretty common unit, so we don't use the variable that matches with the unit. And there is no lowercase v unit, because voltage is uppercase v, which is different. And so yeah, that's just why how we do what we do. Okay, so speed is lowercase v, velocity is v with an arrow above it to signify that we're talking about the vector there. And then we've got, so v equals d over t, and velocity equals displacement over time. V vector equals d vector over t. That's how those get all written down. I should have given that to you on Friday, and I didn't, and I'm sorry. Because how I give all of the answers here is in terms of d's and v's and vectors and whatnot. So I know this is small and a little bit messy, but these are my answers here. For the d and v, distance and speed, we should all get the exact same values because they give us the distances along the path, and distance takes into account the path that you took. So if you went from Fizzlestein to Quatsov, that is 75 kilometers. That is the length of the road from Fizzlestein to Quatsov. Because if you're following that distance, you're not flying there, you're following the road. But if we want displacement, that is the measured straight line distance from Fizzlestein to Quatsov as if you flew direct. So my measurement there was 4.2 centimeters, and we're told that 1 centimeter is 10 kilometers, so 4.2 centimeters is 42 kilometers, and so that's how I came up with that. So our distances, or our displacements and our velocities will likely be a little different, depending on how you measured. If you went center to center, it's going to be different. But if you're close, we don't have an issue here. So these are my answers. This set is question 1. This set is question 2. This set is question 3 is actually really hard to read because I was really tiny and kind of messy. That's 208 kilometers, and so that's 104 kilometers per hour. But because we went back to Rasissa, sure. Our displacement is 0 because we ended where we started. So our velocity is also 0. And then these ones here, this is question 4. And this down here is question 5. Comments, questions, concerns. I'm sorry if that's unreadable. I made some mistakes and did it in pen, so I apologize. You don't have to take a picture of this, Jasmine, because it's in the video. And that'll be posted today. So you're welcome to if you want, but you certainly don't have to. Yeah, you don't ever have to take a video. Take a picture. The video will always be there. So questions, comments, concerns on any of this? Naya, sorry, you almost put your hand up? Almost, but not. Okay. Yeah, James. A little bit. My best guess is it shouldn't be off by more than 2 kilometers. And so that means your velocity is off by a little bit too. Again, but not a lot. So yeah, you can have, like, short answer is yes. Within 2 kilometers, I think is reasonable. Any other questions, comments, concerns on this? We're good? If you didn't have a chance to do that, you've got some time. Well, you'll have, time after school today, I'm sure, to take a look at this stuff. But otherwise, that was it. So no comments, questions, concerns. Fantastic. If you, so that's that. That was Friday's lesson. Let's do today. Bam. Today's lesson, if you haven't got the paper, is sitting out back by the door. It's just average velocity from calculations. So this is arguably easier than the stuff from before because we're not actually doing any of the measuring. And I've got some new people here. So Tanjot is now here. Abdul, why are you here? It says you're excused. You attend. Oh, wait, hold on. Maybe I'm on Fridays. I'm totally still on Fridays. You were excused on Friday. I need today's attendance. Never mind. If you were away on Thursday and didn't write the test, you still need to do that for me. I hate my ed. Come on, you slow thing. Here we go. So, Tenja, I marked you away, but you're here now. And so I'm just missing Indu and Angelina. Cool. Tenjot, favorite dessert? Sorry? Apple pie. Fantastic. Okay, so we've kind of already gone through a large portion of this lesson today. We're going to do it again just because I know some of you are still fuzzy on unit conversions, and that's okay. And now that we're actually going to start doing calculations, just basically glorified word problems, we need to make sure that I address a few kind of pointed details. The most important thing when you're actually doing these physics calculations is to make sure that the units match. Really quite important, totally necessary. So if I have a distance in meters, a time in seconds, my velocity should be in meters per second. If my distances are in kilometers and my velocity is in kilometers per hour, my time has to be measured in hours, because I want to be consistent. And hours is actually HR. If my time is in minutes, my velocity is in meters per minute, then my distance needs to be given as a meter. Cool. And then I've got kilometers. I've got kilometers per day. So time should then have been measured in days. So we just got to make sure that we're consistent with our units. And then life goes well. If the units don't match, you have to convert, which we've already kind of done. The shorthand conversion from meters per second, and I wrote it once. We're going to write it again. Yeah. The magic number that you need to remember is 3.6. To go from meters per second to kilometers per hour, we multiply. And to go from kilometers per hour to meters per second, we divide. So, 75 kilometers per hour is how many meters per second? You want to try that again? It's definitely not 6. Should be 20.83 repeating. Because to go from kilometers per hour to meters per second, we're dividing by 3.6. 75 divided by 3.6. That still begs the question how you got 6, but that's okay. Oh, no, that's question 1. That is a common mistake, more often than you might think. That is question 1, 75 kilometers. This is question 2. So don't include that 2 in the decimal place. That makes way more sense why you did that then. Fantastic. Yeah, important to recognize, this is the question number. This is the actual question. 15 meters per second is how many kilometers per hour? 50. Cool. And 50 kilometers per hour is how many meters per second? 13.89. Cool. There's some other times you might need to convert. And again, we've kind of already done this, but we'll do it again. Days to seconds. This is an application of what I called the factor label method before in that first unit. So if you have 306 days and you want to go to seconds, how are we going to make this conversion? Well, do you know that off the cuff?
I swear I've heard the number before.
So short answer is no, though.
Yeah.
Because if you swear you've heard it and can't give it to me, you don't know it. So if I'm going to go from days to seconds, and you don't know what that magic number is, what is an intermediate value you do know? You know hours. Hours. Days go on the bottom because we have days on top and we want to cancel those. We want hours on top. So what's the relationship between hours and days? 24 hours in 1 day. That's going to cancel out my days because I've got them in the numerator and the denominator. And now I don't want hours, I want seconds. Can you go straight from hours to seconds? Well, if you know the magic number, you could go straight from hours to seconds. But if you don't know that it's 3,600 seconds in an hour, we could go straight to minutes. So my hours are going to be on the bottom. I'm going to put my minutes on top. Cancel my hours. So 1 hour is how many minutes? 60 minutes. And then the same thing here. Now I'm going to go from minutes to seconds. Minutes are on the bottom because I want to get rid of those. So my seconds are going to be on top. The relationship between seconds and minutes is? How are seconds and minutes related? 60 seconds in 1 minute. I multiply across the top. I divide by what's on the bottom, but I don't have anything other than 1. So it's going to be 306 times 24 times 60 times 60. How many seconds are there in 306 days? Sorry? You have an iPad in front of you and you're not using a calculator? You're going to say 12,000? Yeah, the Tristan, what'd you get? No, who was it? Tenjo? 26,438,400 is the correct value. So a little bit more than 12,000. Yeah. Out by 3 zeros. So an order of 1,000. 1,000 times bigger than our guess. I mean, you're in the same solar system, but okay, do some conversions. You do these 6. Take a couple minutes. Actually do them, Manuel, on your market take giver.
So every time you mention convert days to seconds, you need to multiply by 800,000 64. I'm confused about it. No, you need to multiply by 86,040 to back to the days to seconds.
Technically, yes, but I'm not going to expect you to memorize 86,400. You could just, if you know it's 86,400, sure. But you could also march it through like this. 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute, and you multiply these 3 together. I care far more that you know the procedure than that you've memorized 86,400. But if you do, that's cool too. Procedure's more important though. Manuel, wake up. Yeah. Have you done any of these 6? Okay, go back fast and come back. Okay, we done? Check your work. It's up there now. Cool. Comments, questions, concerns. Yes, sir.
In question 5, you don't use like the commercial year that's 360 days.
365.
Oh, okay. Because like in Brazil, we like learn to use instead of 365, 360 because like I don't know why we call it commercial year.
I've never heard of a commercial year. What do you do with the other 5.25 days?
Like just to make the easier to find the numbers.
Interesting. Yeah, no, that's we have calculators. I'm gonna go exact.
No,
If it's mental math, I could see maybe why you do that.
Yeah, because we don't have calculators.
Yeah, well, yes. In this class, I am all about using the tools. My math nines don't get to use calculators, but everywhere else, you've got the tools. Let's use them.
A commercial year is a 360-day period composed of 12 months of 30 days that is used by some businesses and non-profit or profit organizations to internally track changes in accounts. They don't use the 15 days.
So yeah, okay. So the February becomes a 30-day. What happens? We're still missing some days then.
I don't know. Wait, how many months is there less than 30? Is it
We're still missing 5 days. Whatever. People do what they're going to do. Flip the page. If those are easy, great. Distances, these are conversions. These are arguably easier conversions. Going from meters to kilometers and kilometers to meters, meters to centimeters. This is something you've already done. I hope this is relatively straightforward. Meters to kilometers is multiplication or division by what value? And what are we doing? In this case, going from meters to kilometers, we're dividing. Almost got you. So 20, because there's 1,000 meters in a kilometer, so 23 meters divided by 1,000, that's going to give us 0.023 kilometers. Kilometers to meters. Again, you can, like, I mean, think of, I don't really care how you choose to think about it. But one of the ways you can think about it is by recognizing what these prefixes actually are. Kilo means it's 1,000. So if you have 1,012,000 meters, we're dropping the kilo, we're multiplying by 1,000 to replace the fact that we just pulled out kilo. So this is going to give us 12,000 meters. And then meters to centimeters. Centi means 1/100th. So if we're adding centi, we need to divide by 100th, or multiply by 100. There's a whole bunch of ways you can think about this. There's 100 centimeters in a meter, so we're multiplying by 100 to give us that 500 centimeters. The conversions for distances should be really quite easy. 0.53 meters, I'll just rattle them off here for you guys. 0.53 meters is how many centimeters?
Oh.
Sorry? 53. 130 meters, how many kilometers? 0.13, I heard. Because we're dividing by 1,000. And then 1,200 kilometers is how many meters? Sorry? 1.2 million. Or 1,200,000 meters. Again, the distances are nice and easy. Typically we're multiplying and dividing by powers of tens, or just adding zeros and moving decimal places. Those ones should be straightforward, unless I start throwing miles and stuff at you, in which case I'll give you the conversion for that and you have to use it properly. So there's a possibility it happens. It's phenomenal. Why can't the US be normal in a whole bunch of different ways? Okay, so typically you'll be given this information quoted to you as an average velocity problem. So what you need to recognize is that we'll be given an equation. Now we're going to start pulling stuff off the back of our formula sheet. So we have a speed one here. Speed equals distance over a change in time. Because the computer didn't have a graphic for arrow when this was first done, they do now, but when it was first done, I haven't felt like retyping it. They just put the bar on top. That's how we symbolize vector on the back of our formula sheet. So if we're looking at our average velocity problems, average velocity is given to us as velocity equals displacement over time. You may also see it given, they actually quote it like this on your formula sheet, VAVG. So velocity average, this is shorthand for average, is equal to your total displacement over your time. That's the third formula, actually, total displacement over total time. And the reason they specify between these two is this one is really straightforward, makes a lot of sense. if there's only one scenario happening, I give you a single distance and I give you or displacement and I give you a single time and you have to tell me what the velocity is. This one is if I say, okay, well, this much displacement in a little bit of time, and then they did this, covered this distance in this amount of time, and then they covered this distance in this amount of time, and then they covered this distance in this amount of time. To find your average velocity for all of that, you need the total displacement divided by your total time. So you have to combine things for that. But effectively, they're giving you the same set of, same formulas. Yeah?
So for velocity, you say like the direction.
Sorry?
For velocity, you say like which direction, right?
Yes, but it's the directions will be given to you in the questions that you're given.
Yeah, okay, but if that's into the average velocity, what would be the average distance? What's the section of motion?
Say that again.
If the question says,
What's the average velocity?
yeah,
Yeah.
and what would you write for the direction then?
Whatever the final displacement is.
Okay, cool.
Like if you're so let's do an example, shall we? Do I give you one of these? I don't give you one as gross as I could. But like I said, if the question was this displacement in this amount of time, and then this displacement in a different time, and then this displacement in a different amount of time, and then this displacement in a different amount of time, your final displacement is always your final position minus your initial position. So this, because this is where you started, that would be the direction of your final displacement. Are you guys familiar with the velocity displacement time triangle?
What?
Okay, clearly not. That's cool. This is the formula that you're given on your formula sheet. But I'm not going to always say find velocity. I'm going to say, here's your information, find displacement, or find time, or whatever. This is a relatively simple equation. I mean, it's easy enough to manipulate it. If I tell you to find time, how would you isolate this thing for time? Manuel. You multiply both sides by t. On the side that's going to cancel, and you multiply both sides by v. V is going to divide down. So time is going to equal displacement over velocity. That's what you just said. Okay, cool. There is a handy tool for dealing with equations like this with 3-variable multiplication division style questions. And it's shorthanded as a triangle. Sometimes it shows up in math. I teach it to my Science 9s because we do it for a current, the relationship between a current, a resistance, and a voltage, which you guys should have all done in Science 9, I hope. And the triangle looks like this. In this case, it looks like velocity down here, displacement up here, and time right there. We've seen this before.
Yeah.
So then the one that you're looking for, you cover with your thumb. So velocity I cover up with my thumb, and I've got displacement over time. Or I can cover up time, and that's displacement over velocity. And if I cover up displacement, that's velocity times time. So beside each other in a triangle. So that's a handy little shortcut for those of you who like such things. It's a handy little tool. You can feel free to memorize that if you want. I'm not going to toss it on your formula sheet. But things like this, we'll have a different version of this exact same triangle when we do circuits in a month or so, a couple months. Cool? There is a particular way I want you to set these things up when you're solving some of these problems. The first thing I want you to do is I want you to list all given and unknown variables, and I want you to make sure the units match. I want to see your work. I don't want you just to fly through it in your head and slap stuff down. I want you to start outlining a procedure. I know already you're going to be like, I can do this in my head. The answer is blah. You will not always be able to just rattle it off in your head because the math is going to get more complicated, the concepts are going to get more complicated, and the way the questions are presented to you is going to get more complicated. And so I want to show you a set of steps that I want to outline and that I want you to follow while you're going through this. And the reason I make a big deal about this is because I tutored a kid once. He was in my sister's grade. He was struggling. It was Physics 12. He was struggling in it. He had the same teacher I had in Physics 12, who's a really nice guy but wasn't a great teacher. And yeah, he was a super nice guy. He just didn't teach us things. We learned more from the textbook. And teaching my sister's friend, or tutoring my sister's friend, I gave him this procedure. I said, okay, so you say you don't understand all of these things, but I don't think that's your issue. Follow through these problem-solving steps with me, and we'll do it. He's like, I don't need problem-solving steps. I actually need to, understand this. I'm like, you will. Just do this. I tutored him once for 45 minutes, and I tutored myself out of a job. Because he just didn't have a framework for his thoughts. And if you have if you devise a framework for your thoughts, this goes so much easier. And so here it is. Here's what I want you to try. First thing you're going to do is you're going to list all given and unknown variables from whatever I've given you. In this case, this first set of simple questions is all just going to involve velocity, displacement, and time. So maybe we don't know velocity. That's great. Write down V equals question mark. Let's say I give you a displacement. I tell you the displacement is 10 meters, and I tell you the time is 2 seconds. However the question is worded, this is the first thing you're going to write down. Everything you know and the thing you're looking for. So there will always then be a formula that relates these things together. In this case, the formula is V equals d over t. And then we fill it in. Well, my velocity is equal to my displacement, which was 10 meters, my time, which is 2 seconds, and then you actually solve the thing. V equals 5 meters per second. And again, this is going to get more complicated, I assure you, but right now it's still fairly easy. And you're done. Box your final answer so that it's easy to find and call it a day. Typically, this will be 4 marks. 1 for doing this. If you have no idea what you're doing, you can get 25% just by writing something down. You betcha. That's how I have to force the issue. I want to see a formula. Show me that you know the relationship. Fill it in and solve it correctly out of 4. If all I see is a final answer, you're not going to get it. There'll be marks you'll have left on the table. So an example problem, nice and easy. What is the average velocity of a dog that runs 45 meters north in 5.5 seconds? Well, I'm looking, it says what is average velocity? So that's what we're looking for. It's running north 45 meters. So what is that? That's a displacement because they've given us a direction there too. 45 meters north. And they've given us our time. Time is 5.5 seconds. So the relationship here, velocity is equal to displacement over time. And now we fill it in. 45 meters north divided by 5.5 seconds is going to give us a velocity in meters per second, and the direction is already given to us there is north. What's the you said 8.18 meters per second. In anything I give you, if you're missing this, it's a half mark gone. If it's a vector and there's no direction, it's a half mark gone. If I ask you for a distance and you add a direction, I'll take off a half mark for that too. I want you to make sure you understand. What I want to know is that you understand what you're looking for and the information that is required to go along with that. Cool? Comments, questions, concerns? And flip the page. There's some easy stuff for you to try. Actually, hold on. I lied. Do I have to go through some more of these with you? Let's go through some more of these. These first ones are all examples, and then you've got some stuff on the bottom. So number 2. What is the average velocity of a person who runs 21 kilometers in 2 hours? This one is the exact same setup. Is it absurd?
No, it's actually not.
I'm looking for velocity. I'm given a displacement, though they don't tell us the direction. So they don't give you a direction. You don't have to deal with a direction. And the time is 2 hours. So V equals D over T. Again, you can pull that straight from your formula sheet. It's going to be 21.1 kilometers in 2 hours. I got 10.6 kilometers per hour. I mean, he's moving, or she's moving, but it's not out of the realm of totally doable. I mean, assuming you're a runner. I couldn't do it, but I'm sure someone in this class could. Cool. Next one. If a ball is thrown 25 meters per second downward, what is the displacement after 0.65 seconds? There's a note I want to make on this one. As things fall, what happens to them typically? The speed increases. Why does speed increase?
Because they're falling for a longer period of time where their weight is added.
What's the thing? What's the thing that causes the speeding up? Gravity. Connor, I love that. Yes, I love that you're giving me complicated answers, but I was looking for a one-word answer. Gravity, right? Eventually, we will include gravity, but we're not there yet. This is your introduction to kinematics. So we're going to ignore gravity for the time being. Do we have a velocity? You bet. 25 meters per second down. Do I have a displacement? No. So that's what we're looking for. Am I given a time?
Yes.
You bet. Time is 0.65 seconds. So are our units consistent? Well, this one's meters per second, and this one's in seconds. Does that work out for us? Yep. So let's just go through and solve it. You can start with V equals D over T, or you can use that shortcut that I gave you. Either way, if you're going longhand, V equals D over T, you fill it in. 25 meters per second equals D over 0.65 seconds. So I'm going to multiply both sides by 0.65. And I'm going to get a displacement that equals 25 times 0.65 is, you have a calculator in front of you on the desk, man. 16.25, 26? 25. Units on that have to be, careful, meters, because that's a displacement, and which way? Down. The other way we could have quoted this thing is, instead of saying 25 meters per second down, what could I have done right here? Yeah, I could have made it negative. I could have instead put it in there as negative 25 meters per second, which would have made it negative 25 meters per second, which would have given me a final answer of negative 16.25 meters. What you then need to recognize is that negative in this case represents a direction downwards. Either way is totally acceptable. Cool? Comments, questions, concerns? Okay, let's do another one. Do I need to do another one? Yeah, let's do another one. Let's keep going. Two more. 2 people paddle a canoe 450 meters at 2.5 meters per second. How long does this take? So again, we're looking for, actually this is a new one, we're looking for time. We're given a velocity, 2.5 meters per second. We're given a displacement, 450 meters. Are the units on both of those consistent? You betcha. So we're looking for a time. V equals d over t. I'm just going to convert that right away to t equals d over v. Displacement is 450 meters. They don't give us a direction, so I don't need to include one. The velocity is 2.5 meters per second. So my final time is? Cool. One more. A car travels 75 kilometers per hour for 25 seconds. How far does it travel? What do we know? Okay, so we have a velocity of 75 kilometers per hour. Time is 25 seconds. And I want a displacement. Are my units consistent? No. Why? Because I've got kilometers per hour and I've got a time in seconds. So what are we going to have to do before we can actually do anything with this? Convert. Now, it's up to you how you choose to convert. I don't care. Unless I specify units for an answer, I don't care what they are. So you can either take kilometers per hour and turn it into meters per second, or you could turn seconds into hours. It's entirely up to you. Given the values that we're looking at here, which one makes more sense? Taking kilometers per hour and turning it into meters per second, because 25 seconds is going to be a very small decimal answer. So we're going to take this thing, and how do we go into meters per second? Sorry? I hear divide. Divide is correct. Divide by 3.6. Cool. So what's 75 divided by 3.6? V equals d over t, so d equals v times t. And I can fill this in, so it's going to be 75, so, I converted it. Why am I using 75? 20.83 meters per second times 25 seconds. My seconds are going to cancel, leaving me with a final answer in meters, and 520. I had a different value. Why do I have a different value? Oh, did you round it? Or did I round it? 75 divided by 3.6 times 25. 520.83, is that what you got? 20.83 times 25. Cool. So you've got to be careful how you go about these things. If you punch this thing in your calculator, you can use the exact value here by just using the ants function, or use multiply, hit times by 25. So I'll show you what I mean here. So I have 75 divided by 3.6 That gives me that value here, and then if I'm going to multiply that thing by 25, it says ANS times 25. So it's going to use the answer previously. It'll have that infinite repeating decimal. So 520.83. If you round, like I apparently did, you'll have 20.83, the non-repeating decimal, times 25, and you're going to get 520.75. You're out by a little bit, ultimately not a lot. The difference between 75 centimeters and 80.3 centimeters is 6.3 centimeters. When you're traveling at 75 kilometers per hour, 6 centimeters isn't a lot. But there it is. So 520.83 repeating meters is our exact value. If you rounded it to two decimal places at this point, that's not the end of the world. But there we go. Cool. Comments, questions, concerns? Okay. If there are none, I want you to do some stuff here. There's 2 examples here. I'll give you the answers for them. I want you to try these things. For question 1, the speed you should be getting is 0.3 meters per second, and then the velocity is just going to be, in this case, it's going to be the same, but the direction is going to be included. And then this guy down here, you're looking for a time of 0.45 hours. See if you can get that. And then when you've done that, I want you to flip the page and you're going to do a bunch of these. There's 12 questions there I want you to do. And the answers for these are on the bottom. And if I remember right, those answers are not in the correct order. They might be, but I don't think they are. Actually, in fact, I know they're not, because answer 12 is not 53.3 kilometers per hour, because it's asking for a time. So the answers are not in the correct order. So as long as you find the values there on the bottom. You don't have room on this page. Please don't take that as a challenge to do the work on here. So I would love it if you, on your line of paper in that coil book that I gave you at the beginning, do these there. On your mark, say giver.